So for the question of the day, we were trying to figure out which of these two velocities is bigger, negative 30 meters per second or positive 20 meters per second. And this is one of the situations where the way that we deal with vector quantities in physics is a little different than what you might be used to in math class. In math class, or like in accounting or something, you normally would always say a positive number is bigger than a negative number. But in physics, that positive and negative sign are just representing a direction something is going. And we actually get to pick what direction that is. The convention is usually negative signs mean something going to the left or down, but there's no reason it couldn't be something else as well. And so negative 30 meters per second might mean something going to the left at 30 meters per second. Positive 20 meters per second just means something is going to the right at 20 meters per second. And now if we look at it this way as two pictures, or if we think of them in motion, this car going at 30 meters per second, this car going at 20 meters per second, so they would look like this, where the 30 is going faster than the 20, it would seem obvious that the one that has the bigger velocity, the one that's moving faster, has got to be the 30 meters per second. And it doesn't matter what direction it's going, 30 meters per second is always faster than 20 meters per second. Especially since we can ultimately pick which side is going to be the negative side, and so we could even have them flipped around. We could have the 30 meters per second going that way and the 20 meters per second going that way, and 30 would still be bigger than 20. And so when we are comparing our vector quantities, those signs don't tell us anything about how big they are. All they tell us is the direction. The only thing that tells us anything meaningful about how we compare our vectors, which one's bigger, which one's smaller, is by looking at the magnitude, the number in unit part. And so this should go into our daily notes. This is going to be our comparing vectors notes. Because the sign of a vector indicates a direction, not size. It cannot be used to determine which of two vector quantities is larger. If we can't use the signs to figure out which of two things is larger, then the only thing left is the magnitude. So only magnitudes. It's not going to fit. Only magnitudes should be compared to determine which vector is larger. And so if we're only comparing the magnitudes, if we're dealing with like our negative 30 and our positive 20, we ignore the signs, and so we're just comparing 30 meters per second to 20 meters per second. Well, 20 meters per second is smaller than 30 meters per second, and so we would write negative 30 meters per second is greater than positive 20 meters per second. And that is always, always, always how we're going to talk about vectors. This means that the smallest a vector can ever be would be when it has the smallest possible magnitude. And the smallest possible magnitude you can have, if the magnitude is just the number part, is 0. So the smallest smallest possible vector will have a magnitude of 0. So for example, 0 meters per second means that you are stopped. And so a velocity of 0 meters per second where you're not moving is the smallest possible velocity you could have. And so that would mean, for example, 0 meters per second, we would say is less than negative 20 meters per second. Because something that is stopped has a smaller velocity than something that is moving to the left at 20 meters per second. Finally, we should talk about how to deal with when we have the same magnitude but different signs. So, if we have, say, positive 20 meters per second, versus negative 20 meters per second. How do we compare those? Well, if something's going forward at 20 meters per second and something's going backwards at 20 meters per second, we wouldn't say that either one is going faster. And if we were going to say one had a higher velocity, that would be the one that's going faster. Neither one is going faster, neither one is going slower, so we wouldn't say either one is bigger, we wouldn't say either one is smaller, but we also wouldn't say they're the same. Remember, velocity includes not only how fast you're going, but what direction. And since this is going to the right or up or whatever that positive sign means, this is going left or down or whatever the negative sign means, we wouldn't say they're the same either. And so neither positive 20 meters per second nor negative 20 meters per second is larger than the other, but they are also not equal, because equal would mean they're the same, and they're not the same. They are two different quantities that represent two different things going equally fast but in opposite directions. And so neither one's bigger, but they're also not the same. We could say their magnitudes are the same. That would be true. But not the entire velocity. But not their entire velocities. And so when we are talking about vector quantities, which we will do all year, and we want to talk about whether a vector quantity is increasing or decreasing or which one is bigger, since the smallest possible value a vector can have is 0, that means that if something is decreasing, it's getting closer to 0. And so if something is going from positive 20 to positive 10 to positive 5 to positive 1, that's a decreasing velocity. If something is going from negative 20 to negative 10 to negative 5 to negative 1, that is also a decreasing quantity. Likewise, if 0 is the smallest we can have, then anything getting further away from 0 we would say is getting larger. And so a vector could get larger if it was going up in the positive direction, positive 1, positive 2, positive 3, or going away from 0 in the negative direction, negative 1, negative 2, negative 3.